Okay, grade 10s. We're going to again do another review concept from about grade 9, and it's on the number systems. So this diagram here should look fairly familiar to you. I'm assuming you've heard the words natural numbers, whole numbers, integers, rational, irrational, and real. So I want to go through the definitions of each of them again, and then we're going to just do some examples. So hopefully this is a review, and I don't confuse any of you with anything that I go over. So natural numbers are usually represented by the letter N, and they are the counting numbers from 1 and up. So 1, 2, 3, 4, and so on. Whole numbers, usually shown by the number 0, or the letter W, are 0, 1, 2, 3, and up. So there's only one more element in the wholes than the naturals, okay, which is the letter 0. I know when I was your age, I always had troubles remembering whether it was wholes that had the 0 or naturals that had the 0. And I had a really smart teacher tell me a good way to remember is whole has the 0 in it, whereas naturals does not. So that's the way I've always remembered it in my head. It's just a little catchphrase that I use. Integers are your positive numbers, your negative numbers, and 0. So like -8, -15, 0, 1, 2, 3, and so on and so forth. Now, what is super important within this bullseye? Okay, so those first 3 levels, naturals, wholes, and integers, have no fractions and no decimals. So if you are a fraction or a decimal, you cannot be whole, natural, or integer. So where do the fractions and decimals come in? They come in right here for rationals. Now, rationals we show by the letter Q. If you're wondering why Q, I really think it's because every other letter was taken. Now, rationals, a good way to remember them, these are any fraction, okay? They're also any stopping decimal. They're any repeating decimal. And they're also any integer. Because notice how I drew this. This area right here contains, so rationals contain integers, contain natural, contain whole. Okay, so you kind of read in on it. Okay, so rationals are our biggest number system. So essentially, if you want to guess at what number classification a number is, guess rational. Most of our numbers are rationals. Okay, so the reason why integers are considered rational is because let's say the number 5, 5 can be written as 5 over 1, which is a fraction, or it can be written as 5.0, which is a stopping decimal or a terminating decimal. Okay, 15%. 15% can be written as 15 over 100, which is a fraction, so therefore it's a rational, or it can be written as 0.15, which is a terminating decimal. Okay. 3.153 with the bar over the top means 3.153, 153, 153. So that is a repeating decimal. Okay. Negative 2/3. Negative 2/3 is a fraction. Now, if you don't match any of those conditions, you are an irrational number. The way we show the irrational is the letter Q again, but we put a bar over the top. In math, when we put bars over top of letters, that bar represents the word not. So irrational means not rational. Now, if you are not rational, that means you cannot be anything else. Okay, so if you're in that side of the classification, you can't be anything else. So you can't be an integer and irrational. If you're irrational, that's the only thing you are. So the irrationals, this is for all the ugly decimals of the world. Okay, those decimals that don't stop, they don't repeat, there's no fractions, there's no nice looking numbers, they're all nasty. The most obvious one is pi. Everybody knows pi is an irrational number. Well, root 3 is also irrational. And the reason why is if you plug this in on your calculator, okay, and I'm going to go through that with you today, you get out 1.71, da 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 da. It's a nasty looking little decimal. It doesn't repeat, doesn't stop. So we say it's irrational. Now, if we put all those number systems together, what we have is something called the reals. Okay, the reals, that's where the R went to, by the way. Okay, so that's why we had to use Q for rational. So every number known to man is real. Okay, so if I say what number classification is 12, and you say R, you really haven't told me anything because every number is R. So when you're asked to classify numbers, we usually don't even bother with the letter R because everything is real. But reals means every single number, no limits, no restrictions. It can be anything. Okay? So I just did this kind of funky little picture here. Most of you know the story about there was an old woman who swallowed a fly. My, oh my, she's going to die. And then there was an old lady who swallowed a spider. She swallowed the spider to eat the fly. My, oh my, she's going to die. Well, that analogy is kind of like our number systems. The natural numbers are the fly. The whole numbers are a little bit bigger than the naturals. So the spider encloses or swallows the spider swallows the fly. Now the chicken swallows the spider, which has swallowed the fly. So the chicken's your integers. Now the cat ate the chicken, which ate the spider, which ate the fly. So within rationals, within the rationals, you have integers, you have wholes, you have naturals. Now, notice here is the dog. The dog is part of the story, but did the dog eat the cat? No. The dog is separated. Okay, so if you are an irrational number, you are still a number. You're still part of the story, but you have not been eaten by the cat. And then if you put them all together, you have this whole fantastic little story and song, and that represents the real numbers. Okay? Okay, so just as a review, naturals is N, wholes is W, integers are I, and within those first three levels, you cannot have any fraction or any decimals, rationals or any fraction, any terminating or repeating decimal, or any integer, because integers include naturals, which include wholes. If you're an irrational, okay, that means you're completely separated. These are the ugly decimals. They don't terminate, they don't repeat, there's no fractions. So what a lot of questions that you're going to get deal with squares and cube roots. Okay, by the way, rationals are shown with a Q, irrationals are shown with a Q bar, and if we put them all together, we get the reals. Now, this symbol right here is what we call a square root, and this symbol right here is what we call a cube root. So if you're asked, is the square root of 27, what number system does it belong to? And you have no idea, what we're going to do is we're going to use our calculator. Okay, so I'm going to show you where those buttons are on the calculator because they're a little tricky to find, especially the cube root one, but we'll go through some examples. Okay, so what I'm going to do is I'm just going to drag and drop these numbers in. Okay, so 3. 3 is a counting number, so it's natural, it's whole, it's integer, and because it's an integer, it's automatically rational. Okay, so 3 belongs to a whole bunch of number classifications. So if I asked you to list the classifications that 3 belongs to in any order, you would just go like that: natural, whole, integer, rational. So you don't have to write out the words, you can just write out the letters, and they can be in any order. -5. So -5, so natural member is 1, 2, 3 and up. Whole is 0, 1, 2, 3 and up. Integer is what this one is. And since it's an integer, it's automatically rational as well. 1/2. So remember, within the first 3 levels, natural, whole, integer, there's no fractions and there's no decimals. So 1/2 is a fraction, so it's automatically rational. -0.6. So again, It cannot be in the first 3 levels. It's a terminating decimal, or it's a decimal that stops. So it is rational. Okay, so now how do we deal with the next ones? So square root 36. So on your calculator, where the square root button is if you find the number 7, go diagonally to the left. In blue, you'll see the square root sign. So to activate anything in blue, we hit second. So you're going to go second, and then you're going to hit the x squared key, and then we're just going to go 36. So notice we get out the number 6. So 6 is a counting number. It's a whole number. It's an integer. And because it's an integer, it's automatically rational. Square root 12. So square root 12. Okay, so you should know that your calculator screen ended. The assumption that we use in high school is that if the decimal has not come to an end or hasn't shown any sort of pattern by the time your screen ends, you're going to assume that there isn't one. Now, is that a full-on correct assumption? No. But for the purposes of high school and grade 10, it's a perfectly good assumption. So we can see that this decimal has not ended, okay, because it took up the whole screen. 464101615, there does not appear to be any pattern behind it at all. So root 12 is an irrational number. And if it is irrational, that's the only thing it can be. So again, if this was a worksheet, you would just put Q bar beside it because it's irrational. Cube root 64. Okay, where is the cube root key? So on your calculator, you're in math class, so hit the math key and look at right beside number 4 is the cube root. So you have 2 choices. Option number 1, you can hit the down arrow till you get to number 4 and then just hit enter. Or you could just hit number 4 on your keypad and it will automatically select it for you as well. So cube root of 64 is 4. Okay, so is 4 a natural number? Yep. Is it a whole? Yep. Is it an integer? Yep. And since it's an integer, it's also rational. Look at how full that rational bucket's getting. Remember I said most numbers are rational? And then pi, so you do have a pi key on your calculator. It's written right beneath the power, right above the power key. So you go second and then hit the power key, hit enter. And again, 15192654, da 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 da, forever and ever and ever. Doesn't stop, doesn't have a pattern. So pi is irrational. Okay? Now, in grade 10, we focus on rational and irrational. Junior high was more about the naturals, wholes, and integers, whereas high school is more about the rationals and the irrationals. So negative 3/5, root 14, and cube root 8/27. Okay, so negative 3/5 is a fraction. Fractions are automatically rational. Okay, so fractions are automatically rational. Okay, for square roots and cube roots, you're going to use your calculator. So square root of 14. So square root of 14. Okay, so does that seem to have a pattern? Nope, and it didn't appear to end. So this one is irrational. So you can either write the word irrational or put the Q with the line across. Cube root 8/27. So again, hit math, pick number 4, 8 divided by 27, hit enter. Okay, so 0.6666667, and again, the 7 is there because it rounded it, because the screen ended, but the decimal didn't. However, this is a repeating decimal. Since it repeats, it is rational. Okay, they're the nice looking decimals. Okay, last thing we're going to do is number lines. So when you do a number line, and remember, the numbers always get smaller when you head left and always get larger when you head right. So what we're going to do is we're going to figure out what the decimal equivalences are of each of those 5 numbers, and then we're going to plot that on our number line. So we're just going to go through and use our calculator. So cube root 13. So math number 4. So cube root 13. So that's 2.35. So I'm just going to write that right underneath it. Square root 18. And we get 4.24. Now you should know the square root of 9 is 3. I'm going to skip this one for just a second. I'll come right back. Cube root of negative 5. So math number 4, negative 5. That's negative 1.71. Okay, so we haven't done a fourth root yet. Now this is going to be a little bit different depending on which calculator you have. So for the TI-83 people, for the fourth root of 27, what you're going to do on your calculator, you're going to first enter the number 4, and then you're going to hit the math key, and then you're going to pick number 5, and then you're going to enter number 27. For the TI-84 people, okay, you're just going to go straight to the math key. You're going to pick number 5, and then you're going to hit 4, and then you're going to hit over, and then you're going to hit 27. Okay, so I'm running the TI-84, so I'm going to hit the math key. I'm going to pick number 5. I'm going to hit a 4. Notice that little arrow appears, and then you hit 27, and you hit enter. Now again, if you were running the TI-83, you'd hit the 4 key. So on the TI-83, what your screen's going to look like, it's going to look like this. It's going to be 4x root 27. That's what your screen will look like. The calculator knows that the 4 goes in the x spot. Whereas on the TI-84, it automatically puts it in that spot. So you'll get out the same answer, both of you, but again, it's just the way the calculator appears. So 2.28 is the approximate decimal. So again, the reason why I did that first, excuse me, is I want to know where the range of my numbers are. So my smallest is negative 1.7, so I need to go down to negative 2. And my largest number is just over 4, so I need to go to just over 5. So you want to give yourself a lot of space there between the numbers. Now, when you write the numbers on there, you write the numbers you were given, not the decimals. So 2.35 is right about here. So you write cube root 13. Do not write 2.35. Root 18 is 4.24. Square root of 9 is exactly 3. 2.28. Now look here, this is 2.28, this is 2.35. So I'm just going to do this one just ever so slightly below it. And that one's the fourth root of 27. And then negative 1.71. So that's the cube root of negative 5. So there are some concepts in this course that are meant to be done on the calculator. This is one of them. Okay, this is why we want you to have that calculator as soon as possible, so you learn all those tips and tricks to deal with it. So as always, the assignment is attached. And so again, as you're trying it, if you have any questions, please don't hesitate to ask. We'll see you in the next one.